Hello and welcome back to release day, really. Today is episode 12 in our journey of converting Blitz BASIC 2D, pretty much, into PlayBASIC. So I built a release of the current state of the tool, and it's on the forums in the pretty much the work in progress thread, this blog, whatever you want to call them. I tend to try and put all of the conversation about one idea in one thread, so you can follow through what's happening, etc. If you feel like it, you know. We can go and download from here, but of course I've got the tool sitting right here in front of us. Let's have a quick look at it. Pretty basic, isn't it? Nothing pretty. Probably a bit of a change since the last time you saw it. I'm not quite sure. Got a home button there, which will take you to the PlayBASIC home page. I didn't want to have an info or about window. I thought of that and just thought, I can't be bothered. I'll just have like a home button for it. So the tool works the same. Use load source code. I'll use the Taurus source code again. Apologies, because you've seen this a million times. If I hit remove, it just removes that from memory. I'll load again. It doesn't delete the file, it just removes it from in memory at the moment. We've got a temporary view over here. I can move to different projects if we load more than one source. We'll just check that. Go up here, load one of those, what's a longer one? That one, image, Blitz image. So we're looking at Blitz image functions. It'll either load files with an extension of text or an extension of .bb, by the way. So you just move forward and back, between what project you want to be looking at. So if you change project, then you're removing this project from memory or exporting it or viewing it. So we'll look at the Taurus example here. So we'll hit view, have a bit of a squiz at it. Same old. You've seen this stuff a million times. It translates the whole program now, except for the collision issue in this particular one, which occurs in these type declarations here. Notice how we've got vertex array of type vertex. That's not legal PB code. So to run this, we'll have to rename those. But the other issues that were in older versions, like if we go to draw edge. So in the older version of their code, in the original Blitz code, it was doing a shift and an addition. See over here, and I did say shift. And I tested Blitz and I tested PB side by side with a bunch of these conditions. And it turns out that if you have a shift with an addition or a subtraction, the precedence is different. But if it's a shift followed by a multiplication or a division, they seem to be the same. So I've had to insert brackets in this particular case. So if that occurs in other programs too, this should actually solve that problem. Beyond that, it's all the same as what it was before. I hit export. We'll get a tick for saying the code's being exported. I could just show those shift operators up down here somewhere too. So let's have a look. So it's important that the translator tries to mimic the mathematical behavior of Blitz, even though they are two different products. There will be differences in the way expressions are resolved, etc. The precedence of some things. It's quite common where you move from one language to another. So an expression that's fine in one language may not, work in another one. It happens then. So here I'm just testing the shift with an addition after it. The pink brackets here are to demonstrate that the translator inserted the brackets around the shift to protect the order of operations. I compared the two in Blitz, and the shift followed by an AND is fine. I've just trying here with brackets and variables, and inside the parameters from a function, etc. Well, there you go. There's another one there as well. So in Blitz, there's an SAR operator. We don't have that, so I've had to implement this as a function. So it'll remap those SARs into a function call that does the same thing. Just as it's not inlined. That's all. I'll go back to the bigger one, the Taurus source code. So if we hit home to go to the top of the code, I've added a few things in here extra. So if I right click, I've got optimize, so I can see just the sort of the compressed additive subtraction operators. We can do other things too. We can strip null lines. We can add function headers, which adds these. There's one there. Our function headers. And we can strip null lines, which will remove any redundancy between lines. We can toggle remarks, but they're always kept on in the export. So that's really just to check. We're looking at code pretty much. Because sometimes code, if you have lots of remarks around code, it can be confusing what's code and what's not. Turn remarks back on. Close, get out of that. I'll hit export again, and that will export a new version than the one we just did before. Alright, so if we open up our examples, I'll grab the last version of this. This is the 3D Taurus demo. So I generated a folder with a PBA project, and copied the current wrapper, which is just as we'll see in a second, it's the emulation of the Blitz functions. So if you add more things that you want to support, you can add them to the main wrapper, and I'd suggest actually duplicating that or sharing them with other people, or make fixes with it or something. But it copies the wrapper in, makes a project file, and dumps all of your Blitz code into this main for our PB project. Just drag and drop it across. So it's our code as we're pretty used to seeing it by now. We still have that. We have one fault with this particular example, and that's the collision with the vertex, the type names and the vertices. So I'll rename our types. I'll just put a T in front of them. Now I might do this in the tool itself to prevent this from happening in the future, which would mean this would be one example that would that would translate and run straight away. To be honest, I wasn't expecting anything to ever translate and run straight away. You know, it's how things go. And here we are, we're running straight out of the box. We had to fix the type collision name problem, but we don't have that shifting error anymore, and the code actually works. Now it's the same problem with the time. Is that our overzealous buffer locking? It's more efficient just to lock the buffers once, then draw everything and then unlock them. As you've heard me say now a gazillion times if you watch these videos. There you go. Now I'm pretty happy with this. You know, when I started this, a few months ago, I didn't actually think we'd get anything to work in So getting something that's relatively complicated to work is actually pretty impressive for me. To make other programs work, you'd have to add your own emulations of these things. If it sees a command in your program, in your Blitz program, it'll just output it as _BB. So the assumption is that you'll provide a function that does that equivalent thing, whatever it happens to be. If there's no function, then it won't compile it when you import the code into PlayBASIC, of course. It just can't conjure up things out of nothing. My objective is not to go through and try and emulate Blitz and try and clone it or whatever. It was just to get a way of translating my own old Blitz code to PlayBASIC. And by extension, anyone out there who has Blitz code who might be interested in PlayBASIC, etc. So it just removes one of those barriers to entry for some people. And as you can see, it actually runs pretty well. I did get a question from one guy suggesting to me that, well, I'll go there. Okay. I did, this person was asking about, well, it looks kind of okay running in PB, but surely the original Blitz code is much faster. And I had to say, well, no, it's not actually. And it really comes down to, we put a lot of onus, a lot of work into PB, fixing on stuff that you just wouldn't normally do. In Blitz, it's perfectly, the reliance upon, the compiled to machine code model is very high. So everyone's caught up in the assumption, oh, if we build everything in machine code, that's going to make our applications fly. It does for some things, and other things it doesn't. Primarily when you look at command set operations, like dealing with strings in Blitz and Dark Basic and a bunch of these other products, they're quite horrific, really. So we lose out in some areas because Blitz is much faster with number crunching, absolutely. But we win back in other places where you might not expect. So it's quite often what happens is programs run pretty much the same. I just cleaned up a bit of code in there. Gives us about 60, averaging 42, peak of 62. We haven't replaced the dot function or anything like that. Drawing edge, where's the dot function, the render loop function. So fast dot, so X, Y, RGB, RT. By now you've seen me write the same code a million times, if you're pretty bored about it. Get rid of those two things there. And that would make our inner loop, still very comparable. So, but we've peaked now at 83 frames per second. We're heading towards an average of around 54 frames per second. It's terrifying, really. But this is a fairly complicated Blitz program. It's I chose it because it's kind of similar to the same kind of structures that PB has. The converter doesn't really support have LinkList support in it today, right? You have some type support. It's very preliminary. So most Blitz programs that are heavily list orientated will have to be manhandled by you at the other end. It's just the way it goes. They just function very differently at the time between the two, and at the time I don't have much more time to implement or to try and add these things to it. Definitely we'll come back and add more to it. Alright, just pasted our torus example into Blitz. This is Blitz Plus, by the way. let's run this. So it's suffering from the same buffer locking problem that what we have as well. Everything in direct draw pretty much has this problem these days. All right, so as you saw, it's running, the same kind of basic problem that which is inherent with all direct draw generation applications these days. Anything I run that's direct draw based chokes. So let's draw a poly. We'll just do the same thing. We'll have our lock. We'll lock the current surface. And then unlock it at the very end. And that should give us pretty much the same result. Now we're talking. So we're So we're running here in native Blitz. We're averaging our frame rates around about 56, 57 frames per second. But our peak's about 160. So this is what I'm talking about before about this average performance thing. Is you often get the two kind of cancel each other out a bit. We're not using anything like, here I'm emulating Blitz. This is in PlayBASIC version. We're averaging about 56, 57, but we don't have the peak. The peak performance we don't have, but the average performance is about the same, which just terrifies people because they're like, how is that possible? We spent a lot of time optimizing stuff that other people wouldn't bother optimizing because they're compiling to machine code. We have to make those things faster because we're trying to make sure we don't spit out operations that aren't necessary. We're trying to make sure that things are working the best they possibly can. And this is through the internal runtime from the IDE. It would be quicker in a built executable, but probably not by much. Maybe a few frames here and there, but not a lot. Because all that really does is it removes a lot of the debug elements that are stored within the runtime. So a release build is in PB, or in these old versions of PB, has a lot of hooks in it, checking things to make sure they're okay, like media queries, that kind of stuff. Making sure you're rendering an image that exists, or that, all those sort of things. So in Blitz, we can't really do those things in here. I think really we're crippled in Blitz because of this right pixel. If we take out back buffer, if we just grab that as here, so we're calling a function every time we draw a pixel, which is not that eloquent. This should be faster. Not really. So averaging at 55, 56 frames per second. So there you go. Same system. I'm sure you can optimize this code better than what I can, but let's just try getting rid of that completely. That's better. 56 to 57 frames per second. So now we're pulling ahead of the PB conversion. I think if we unrolled these loops and got rid of the for next loop stuff, and if the buffer's already locked, we shouldn't be calling lock buffer on it. Yeah, a little bit. You know, you have to do better timing to work out how much you're benefiting from each little change. There's a fast version of that, isn't there? What does that do? We're not gaining anything obvious out of doing that. So there's probably a better way of doing that in Blitz. Absolutely. This is old Blitz code in the first place. I mean, same as with PBA. If you wanted to draw a ground strip, you'd use ground strip to draw. All right, let's go back to the tool. One last look at it. I think I couldn't make it much simpler, really. You just load your source code. We'll load text files. Gives you a bit of a preview of this thing. If you have a bit of sticky notes, check them out over here. Some of the stuff in there is really just for experimental purposes, like the collapsing, that kind of stuff. You can hit up and down keys, go through, page up and down, you know, hit back on there. That'll take you to the home page if you want to. If you're interested in how the menus draw one of those things there, it's pretty straightforward stuff. This is just text menus. That code was posted in the forums a while ago. I made one change to it, which is just the rendering aspect of it, wherever that's gone to. Yeah. So instead of drawing a box, I'm drawing a shade box now with a little bit of a drop shadow underneath it for the highlighted item. And the thing that we're hovering over, I'm just drawing that text multiple times. So we're blending it against the background because the text is CRF. So the whole point of CRF is you can do alias font rendering against your effect surface. It'll work on, you know, bitmap surfaces as well, but you've got to read the data from the bitmap to do the blending. It's just easier to do this on an effect surface. So this whole application doesn't use any system services at all beyond the screen. So when you light up something, you know, our favourite test code again. The blue section of screens and effects surface have got effects images over, or AFX images for the icons. The hovering system, you just got two versions of the icon. And it's pre-processed, so we had an alpha edition added to all the RGBs using the box command, and we can just draw the thing with anti-aliasing. What else have we got? The view code here. This is the syntax highlighting control. Got the hovering stuff. I mean, that's all possible because it's a CRF font. So we can color the thing, alias it, etc. And here I'm using one feature of CRFs where you can have a blended against a background color. So the blending's occurring against this common background color here, so it never has to fetch the backdrop color at all. Very handy. It's a shame capturing's murdering the frame rate, but oh well. That concludes my review of it. Quit. There you go. But the code's pretty simple. We're just drawing 3 different versions of it. So one's a very dark shadow, a moderate shadow, and the sort of half shadow. So it's drawn in black and it's blended against the background. Think of that as almost 50%. You know, if I just got rid of those there for a second. So we just got one shadow on the text. So let's just see it underneath there. The same code's used to render the pop-up window here. That's the same code. It's just drawing that to an image, and I'm drawing the image to the screen. It's all in effect. Everything's an effect surface. Go back, restore those bits of code, just to see how little those impact the frame. Just gives a, so they're still there. Anyway, I'll put this version of the menu up in the thread that I posted this in. I forget where it is now. It's on the boards, of course. I think there's only one change, and that's allowing you to reposition, to have an offset of where the menu is happening. So you can, I think by default it draws the menu from 0, 0 down. But sometimes for the pop-up menu like that, I've got a displacement for this top left-hand coordinate, so you can, if you have a pop-up menu, you can set the displacement, and then your menu will appear in that location. Yeah, anyway. If you pick it out yourself, there's heaps of stuff in here that I'm doing that's probably useful, but as a big collective, it's kind of wasteful. This is what I do here, is I don't call sync at all inside my application. I use GUI sync, and that's to take care of the focus. If I run the application just one more time, now if I just scrunch the window up a bit, now if I click on something else over here, the app's still running, but we don't have focus. I'm clicking it back into focus. The beauty of that is it means that if you click away to do something else, the app's not taking up a lot of processor time. It's doing a refresh every, it's dropping the frame rate down to 10 frames per second or lower. So it's going, anytime that I've called sync in the main program, by calling a sync, and we're checking if the screen's in focus. In other words, has our window, is it the currently active window? If it's not, let's do a wait. Do a big long wait, and give a bunch of time that our app might be using back to the system to do other stuff. But we're still refreshing, Anyway, that'll do for this long, drawn-out conversation. Thanks for watching. I hope you find the tool in some way useful. I know you might be watching this in years to come, going, "Why didn't you add such and such?" Well, I don't know. Blame future me on that one. Thanks for watching, and I'll see you next time. Bye.